Okay, good day. So this is the second part of our topic for relation. So at the end of this video, you must to determine the number of relation of a given set, determine the different types of relation, and lastly is to identify whether a given relation is partial order or an equivalence relation. Now let's tackle about the number of relations of a given set. Now we have a formula here that for any set A such that the cardinality of that set represents M, then the number of all relations on A can be determined by this formula, 2 raised to M raised to 2. Remember, makukuha lang natin yung number of relation kapag ka yung set ang given. Now, for example, let A equals the set which has an element of 1 and 2. So since this set has two elements, then the cardinality is 2. So therefore, the number of relations on set A is equal to 2 raised to 2, which is the M, the cardinality raised to 2. Then evaluate this first. 2 raised to 2, of course, 4. Then 2 raised to 4 equals 16. Now, these are the different relations on set A. So we have a relation which has 4 ordered pairs. We have also relations with 3 ordered pairs. So they are unique. We have also by 2s. We have also by 1s. And we have also the empty relation. Now as you notice, we have 16 relations, okay, on set A. Ngayon, pwede rin natin kunin yung number of relation given yung another relation. So for example, the relation from A to B. So this is the definition. The number of relations that can be defined from set A to B is the number of possible subsets of the relation A to B. If the cardinality of A represents P and the cardinality of B represents Q, then the cardinality of the relation from A to B is equal to PQ. So we just have to multiply the cardinality of each set, and the number of subsets of the relation AB is determined by the formula 2 raised to PQ. Okay, remember pagka-relation yung given. So, for example, let A equals 1, 2, and B is SO. So, since NA or the cardinality of A is 2 and the cardinality of B is 2, then PQ equals 4. So, here, so we have to multiply the cardinality of each set. And therefore, the number of relations on A times B is 2 raised to 4 using the formula. So it's also equal to 16. Another example, let's make use of H equals 1, 2, 3 and I 4, 5, 6, and 7. So how many relations do we have from H to I? So since the cardinality of H is 3, the cardinality of set I is 4, then we'll have 2 raised to 12, okay, which is equal to 4,096 subsets. Okay, so marami yan. So it's time consuming kapag isusulat natin lahat. Okay? So ang importante, alam natin kung paano kunin yung number of relations on a given two sets. Let's proceed to partition of a set. Pag sinabi nating partition, kung paano natin hahatiin yung isang set into its subset. So by definition, a partition of set A is a collection of non-empty subsets. So meaning, hindi kasali yung null set or empty set that satisfies the following conditions. So first, yung union ng lahat ng subsets ay dapat yung set mismo. Second, yung intersection naman lahat ng subsets na yon ay empty set or null set. Okay, for example, let's have this set A whose elements are A, B, C, D, and E. So paano natin ito hahatiin into its subset? Okay, so pwedeng hatiin natin ng tig-isa. Okay, so we have a set containing A. We have also a set containing B, C, D, and E. Now, let's check whether these sets satisfy these two conditions. Okay, ano yung union ng mga set na ito? Of course, we have A, B, C, D, and E. So, it is also equal to set A. Next, ano naman yung intersection ng mga sets na ito? Of course, if there's no common elements, then it is an empty set. So therefore, since these sets or subsets of A satisfy these two conditions, then we can surely say that this is also a partition of A. Another example, we have this. So we have a set containing two elements, which are A and B. Another set containing an element C, a set containing of an element D, and a set containing of an element of A. So this one is also a partition of A kasi yung union ng apat na set na ito or subsets ay still yung A natin. And then their intersection is an empty set also. Okay? Next, we can also make use of these subsets of A. Okay? Okay, so again, if you're going to take a look at this, the union of these three sets or subsets is just equal to A. And their intersection is also an empty set. Okay? Or we can also make use of these two sets containing an elements or elements A, B, C and another set containing elements D, E. So, ganun lang yung kung paano natin hahatiin yung isang set into its subsets. Now, let's have the second example. List the partition subsets of set A whose elements are 1, 2, 3, and 4 with 3 subsets. Okay, so meaning tatlong sets lang yung gagawan natin ng partition. So, it can be set whose elements are 1, 2, and a set whose element is 3, and a set whose elements is 4. Remember, pag nagpa-partition tayo, dapat yung dalawang condition ay nasa-satisfy. Okay? We can also have 1, 3, 2, and then 4. And then we can also have 3, 2, 4, 1. So as you notice, meron tayong tigtatatlong subsets. So all of these are possible partition subsets of set A. Now let's proceed to types of relations. So first is the universal relation. So by definition, a relation R on set B is a universal relation if each element of B is related to every element of B. So that is R equals B times B. Okay? So for example, the set of all natural numbers is a universal relation. Another is, suppose we have set A equals ON, and the universal relation on A can be 0, OO, ON, NO, and then NN. So this one is a universal relation because all of these are on the relation A times A. Second, we have the identity relation. We have a relation R is an identity relation if every element of set A is related to itself only. Okay, so suppose we have set A equals YES. So the identity relation on A is YY, EE, and SS. So this one is an identity relation. Next, The third type is the inverse relation. So a relation R from set A to B is said to be an inverse relation denoted by R raised to -1 if every domain, okay, when we say domain, it is the values of our x, from the relation R becomes the range, and which is the values for y, and each range becomes the domain. Okay, so the values of x and y interchanges. So for example, if we have the set D equals ABC, then the relation R, so these are the ordered pairs on the relation are AB, BC, DC, and CA. Now, the inverse of this relation, we just have to interchange these two elements. So we'll have BA, we have also BC or CB, then we have CD, and then AC. So the domain here for the relation R, okay, which are the A, B, D, and C, becomes the range in the inverse. Okay, and also the range here in the relation become the domain of its inverse. So that's the inverse relation. Next, we have the reflexive relation. A reflexive R or relation R on set A is called reflexive if AA, which is an element of the relation R for every element of A. And R is not reflexive if there exists an element of A such that AA is not an element of the given relation. Now, for example, if we have the set DABC and the relation is AABBCC and CA, now this one is a reflexive relation kasi take a look at the elements of the meron tayong AA, okay? We have also BB and then we have also CC. Kapag ka walang naulit dito sa elements ng given set, then it is not a reflexive. Okay? So R is reflexive since AA, BB, CC are on R. Now let's have example number 2. If we have the set whose elements are A, B, C, D, and the relation is AA, BB, and then CA. Now take a look at this. There must be CC and DD to make it reflexive. Okay, since walang CC and DD, then it is not reflexive. Next is the symmetric relation. So a relation R on set A is said to be symmetric if there exists AB, which is our element of the relation, tapos meron din siyang kabaliktaran niya, the inverse, BA, we have also a relation or element of the relation R. Okay, for all AB, which is or R, the element of A. So, hindi siya symmetric kapag ka mayroong nag-exist na AB, which is the relation of R, pero pagka yung kabaliktaran naman niya ay wala. Okay? So, let's have this example. If we have the set D, ABC, and then yung relation natin AA, AB, BA, CA, and AC. Now, this one, kapag ka AA, it is automatically symmetric. Okay? Why? Kasi pag binaliktad natin yan, AA, meron pa rin siya dun sa R, or relation. Now here, we have AB. Okay? Pag binaliktad natin to, it becomes BA. So we have BA here. Pasok pa rin siya. Next, we have BA. Pag binaliktad AB, so meron tayong AB. Let's proceed to this ordered pair. CA, pag binaliktad, magiging AC. So we have AC here. And lastly, AC, pag binaliktad, meron tayong CA. So since it satisfies the definition for the symmetric relation, then R is said to be a symmetric relation. Now, example number 2. Okay, if we have this relation AA, AB, CA, and AC. Now, AA again. So, pasok pa rin siya sa condition. Now, AB, so, there must be BA. Okay? there must be BA to make this a relation. Since wala, then it is not symmetric. Next type is what we call the antisymmetric relation. So ito naman parang para lang din siya sa symmetric, pero there is another condition na dapat yung A at B natin ay equal. Okay? So hindi siya nag-exist kapag yung A ay hindi equal doon sa B. For example, if we have the set D, A, B, C, and then yung relation dyan sa set na yan ay AA, BB, and CC. Now, AA, pag binaliktad natin is AA. So, pasok pa rin siya. And also, A is equal to B, A. Also with BB, pag binaliktad is still BB. And B is equal to B. Also with this ordered pair CC, pag binaliktad CC pa rin. And then, they are also equal. So, since this relation satisfies this condition, then this R, which is a relation, is anti-symmetric. Example number 2. If we have the relation AA, BB, CA, and AC on this given set, now let's test if this one is anti-symmetric relation. Now as you notice, AA, BB, pasok siya dun sa condition. Now let's test this ordered pair. CA, pag binaliktad natin, meron tayong AC. So good. Next, the condition must be A equals B. Or yung first element ay dapat equal sa B. So since C is not equal to A or also A is not equal to C, then it is not anti-symmetric. Okay? So ito yung dalawang ordered pair, kaya itong R na to ay hindi anti-symmetric. Next, note that the term symmetric and anti-symmetric ay hindi opposite. Okay? Hindi opposite tong dalawa. Kasi meron yung pagkakataon na yung isang relasyon ay symmetric at anti-symmetric. At meron din naman yung mga relation na symmetric siya pero hindi anti-symmetric. Or anti-symmetric siya, hindi naman siya symmetric. Or pwede naman yung isang relasyon ay wala mismo sa dalawa. Okay, hindi siya symmetric at hindi rin siya anti-symmetric. Now, let's have the last type of relation, which is the transitive relation. So, dito naman, a relation R on set A is called transitive. Pag meron tayong ordered pair na halimbawa AB, then BC, titignan lang natin yung A and C since magkapareho yung B dito. Pag nag-exist yung AC doon sa relation, then it is transitive. Pero kapag walang AC doon sa relation natin, that it is not transitive. Halimbawa, pag meron tayong D equals AB at yung relation na nakuha natin dito sa set D ay AA, AB, and BA. Now, let's test. First, the ordered pair AA. AA, then since this one is an identity, then this is also transitive. Okay? Next, AB. Then meron tayong BA doon. So therefore, there must be an AA doon sa relation. So since ang AA natin dito nag-e-exist, then the relation R is a transitive relation. Okay? Another example, D equals ABC, then R equals AA, BB, CA, AC. Now, yung AA and BB natin dyan, since they are identity, then pasok siya dun sa transitive. Now, let's take a look at this. CA, then we have also AC. Now, there must be CC. Since wala dun sa R yung CC, then R is not a transitive relation. So let's have these exercises. Consider the following relation on the set A, 1, 2, 3, 4. So first relation, 1, 1, 1, 2, 2, 3, 1, 3, 4, 4. Is R reflexive? Now, sabi natin kanina, reflexive siya kapag lahat ng element doon sa set ay identity. So, 1, 1, pasok. But, we do not have 2, 2, and we do not have also 3, 3. Pero meron siyang 4, 4. Since kulang, then R is not a reflexive relation. Is R asymmetric? So, sabi natin kanina, by definition, ang symmetric, pag meron tayong AC, then dapat meron ding CA. 1, 1. So, of course, pag binaliktad natin, 1, 1 pa rin. Next, 1, 2. Dapat meron tayong 2, 1. Pero wala naman doon sa relation. So that violates our symmetric definition. So therefore, R is not a symmetric relation. Is R an antisymmetric? So titignan natin. So dapat equal. Alright? So 1, 1. Of course, that is antisymmetric. 1, 2. And then, since wala naman siyang 2, 1, and pagpa meron man yan, then 1 is not also equal to 2. So therefore, it is not anti-symmetric. Is R transitive? So 1, 1, pasok yan. So 1, 2, then we have 2, 3. So therefore, there must be 1, 3. So meron tayong 1, 3. Next, 2, 3. So since wala namang 3 yung dun sa domain, so hayaan na natin. We have also 1, 3. So wala ding 3 na nag-start dyan. 4, 4. Of course, same lang yan. So it is also transitive. So since pasok yung tatlo, so itong relation na to dun sa transitive, then masasabi natin na this relation R is a transitive relation. Another exercises. Consider the following relation again from set A. Whose elements are 1, 2, 3, and 4. So this relation, 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and then 4, 4. Is this one reflexive? Okay. So dapat meron tayong 1, 1. So meron 2, 2, 3, 3, and 4, 4. So this one is reflexive. Is R asymmetric? So, baliktad ng 1, 1, we have 2, 1. Baliktad ng 2, 1, we have 1, 2. 2, 2, 3, 3, 4, 4, and 1, 1. So, meron tayong, may kabaliktaran yung mga yan because they are identity. So, therefore, R is a symmetric relation. Is R antisymmetric? So, let's test. Of course, this one is antisymmetric because A equals to B. Or A, which is 1, is also equal to 1. Pero dito, 1, 2, 2, 1, pero yung 1 is not equal to 2. So therefore, R is not an anti-symmetric. Okay? Next, is R transitive? Okay, 1, 1, 2, 2, 3, 3, 4, 4 is antisymmetric. So, titignan natin tong dalawang ordered pair na to. So, 1, 2, 2, 1, then kukunin natin yung 1, 1. So, since yung 1, 1 ay meron doon sa relation, therefore, R is a transitive relation. Now, let's proceed to equivalence relations. By definition, an equivalence relation R on set A is a relation that is first reflexive, symmetric, and transitive relation. Okay, consider the following relation dun sa last natin kanina. So since yung R natin ay reflexive, symmetric, and transitive, then this R or the relation is also an equivalence relation. Next, we have also what we call the partial ordering relations. So by definition, a relation R on set M is called the partial order if R is reflexive, antisymmetric, and transitive. Okay? So partial ordering relations. Ngayon, pagka pinagsama natin yung set M tapos yung partial order na R, then masasabi nating partially ordered set siya or yung tinatawag natin na poset. For example, R 1 1 2 2 3 3 4 4. So this one is a partial ordering relation because it is antisymmetric. Okay? Because 1 1 1 equals 2, 2 equals 2, 3 equals 3, 4 equals 4. It is also transitive kasi they are all identity. And it is also reflexive because all the elements on A have this ordered pair. So since it is antisymmetric, it is also transitive and reflexive, then this one R is a partial ordering relation. Next, show that the relation are defined by AB, which is an element of the relation, if A is less than or equal to B on the set of integers is a poset. Na poset siya kasi, first, yung R natin, which is A less than or equal to B, is meron tayong 1 less than is equal to 1, 2 less than is equal to 2. So lahat ng integers pwede nating isulat ng ganyan. Okay? So pagka meron tayong ganito, then it is reflexive. Pwede rin siya sa negative. Negative 3 is less than or equal to negative 3. Next, R is also antisymmetric since 2 is greater than 2 and 2 is less than or equal to 2 and 2 is less than equal to 2. And then since 2 is equal to 2, then it is really antisymmetric. So lahat ng integers natin ay pwedeng ganito. Next, we have also R is transitive because if we have 1 is less than or equal to 2 and 2 is less than or equal to 3, then there must be also 1 less than or equal to 3. So since this one is pasok pa rin siya doon sa relation natin, then it is a transitive relation. Now, since R is a partial ordering relation, pag pinagsama natin yung set, which is the set of integers, tapos yung R natin, which is A less than or equal to B, then this notation, the integer and the relation is a poset. Okay? So, that's all for our discussion on the relation. Thank you for listening and God bless everyone.